All right, this is video 1.3, Theory versus Law. Our first objective for this one is to describe the difference between a scientific theory and a scientific law.
And then we'd like you to be able to recognize some important theories and laws in science, and there's many of them, so we're not going to give you an exhaustive list, we'll just give you some examples of each. And to read along with this, you're going to want to read pages 8 to 9 in chapter 1. So we hear the word theory thrown around a lot. I have a theory about this, or do you have a theory about that? But in a specific scientific meaning, a theory is an explanation that summarizes a hypothesis or a series of hypotheses and which has been supported by repeated testing. So a lot of times when we use the theory, we're not really talking about a theory. It's more of just an educated guess or a hypothesis. To truly get the title of theory, it needs to have support from numerous experiments over a period of time, and so that it's considered to be
Valuable.
factual and valuable. So what are the aspects of a theory, Mr.
So the
Hunter?
first one that we want to talk about is to be a theory, it still has to have the ability to be proven false. That kind of seems weird if you say, well, if I can prove it false, how can it still be a theory? Well, it's not so false that they can just discard it. There's just aspects of the theory that are yet to be fully proven or fully understood. So that's what they kind of mean by being able to be proven false.
Keep the door open okay, this is what we think's going on, but we could be wrong. Maybe we might not have all the information yet. So
and of course, it could be discarded then. If it is proven so false that there's no coming back, it can be discarded
or
and
modified.
Yeah.
All right, so they can be descriptive theories of things, or very often there can also be mathematical theories that describe relationships.
Right. They can provide an explanation for a law. It kind of seems weird that a theory can help describe a law, but sometimes laws, while mathematically are correct and always right,
they don't tell us the nuts and bolts of what, like gravity. We have laws that tell exactly how gravity works. You can predict, a falling object, exactly how fast it's going to be going at a certain point if it's fallen a certain distance. But nowhere in that law does it tell us why gravitational attraction works, what causes gravitational.
We don't know what little
realm of theory.
What little particles in there may be causing it.
Right. And theories, of course, need to be supported by an extensive body of evidence. So they're well documented before they get the title of theory. And they're not easily discarded, but that doesn't mean they won't be discarded or modified if someone comes up with some new evidence.
Like the Earth was flat, well, when they sailed around it, they proved it otherwise.
There we go.
And then lastly, it has to be predictive. It means it can predict future experiments and results of those experiments, of course.
So some examples that we're going to come across in chemistry, the most important one for us is the atomic theory.
Followed up by
So we have a theory about these particles that we study in chemistry, about what they look like and what the components of them are and how they behave.
Secondly, of course, is the kinetic molecular theory. That's when we cover about how particles move. It's quite important to us.
And which helps us explain how gases behave and things like that. We have the Big Bang theory, which in cosmology is kind of the theory of how the universe came into being and what happened in the first few nanoseconds the universe existed. And lastly, then there's the theory of evolution, that living things descend and change over time.
Mm-hmm.
Okay, so all these are scientific theories, and other than the first two we'll definitely touch on in chemistry. The last two, probably not so much.
No. All right, let's go look at laws. Scientific law, and this definition is a rule of nature that has no exceptions. That means if I do X, Y is going to happen. And that's just how laws are. They are usually defined mathematically, meaning if I plug in certain numbers, I'll always get that same answer back. And that's why laws can be so useful.
And if I go out and I try to observe it, I'm going to be able to predict exactly.
If you try to break it, it might break you instead. It's just they don't like to be messed with.
Okay, so some laws that we will touch on in chemistry, we have various gas laws that we'll be exploring. So, for example, the volume of a gas multiplied by the pressure of a gas, V1 times P1, is always equal to the new volume multiplied by the new pressure if you change the pressure. And we actually saw that in the video clip at the end of the last video. That's called Boyle's Law. We have Ohm's law, which you might remember from physics class. V
Oh,
now
not
is
these guys, if they're-
voltage. V equals I times, okay, yeah. Ninth grader, sorry, you wouldn't remember that. You might have learned about this in eighth
Yeah.
grade science. Okay, where the voltage in a circuit is equal to the resistance of, no, the
R is
amperage,
resistance, I is amps.
multiplied by the resistance. Okay, and I know you'll remember Newton's law of motion, and the second law of motion, I believe, says the force acting on an object is always the product of the mass of the object multiplied by the acceleration of the object. And then, of course, we've got other chemical laws, such as the laws of thermodynamics.
And these are laws that are very complicated and not really going to bother you with right now. All right.
So here's your post-video questions based on our theories and laws explanation. They're self-explanatory. Read them. Push the pause button if you need to. Try to write the best answer you can based on the information in the reading assignment. Good luck.
And we'll see you tomorrow.